All right. Hi guys. So we're gonna attempt this to do our notes. So kind of bear with me. Mr. DeVar kind of taught me how to do this, so we'll see how it works out. Anyways, make sure you have your notes open. I'm gonna have my copy of it up so you can kind of type in as you go. If I'm going too fast, just pause the video and continue typing yours, and we'll see how this works. So the notes we're going to be covering today are all about chemical potential energy. So we're going to talk about the atoms. We're going to talk about chemical reactions and thermal reactions. So there are 6 different types of energy. So your 6 types of energy are your chemical, thermal, elastic, electrical, gravitational, and magnetic. So with all of these 6 types of energies, there's kinetic and potential forms of both. So remember, kinetic energy is when things are in motion and they're exerting that energy. Potential is the ability that they have. So both kinetic and potential for all 6 of these, they rely on the motion of atoms. So before we can get into your types of energy, we do need to discuss atoms. So atoms are microscopic building blocks, and they are the arrangement of smaller particles. So these are composed of protons, neutrons, and electrons. Protons have positive charged ions, neutrons are neutral in charge, and electrons are negatively charged ions. This, what you see right here, is an element from the periodic table. So this one is actually silver. What we're going to kind of go through is what all of these numbers mean, the lettering means, and hopefully you will be able to decipher between them once we get going. So for that particular element, this is silver. So the letters Ag, that stands for silver. The number at the top, that's your atomic number. So every single element, it has a different atomic number. What the atomic number tells you for each of your elements is the number of protons that are present. So for silver, it has 47 protons. When we're talking about normal elements, your number of protons and your electrons will be the same. So for silver, 47 is your protons and it's your electrons. Your bottom number, that's your atomic mass. So your atomic mass is going to help you to figure out how many neutrons are in silver and any other element. How you figure out your neutrons is you take your atomic mass, and we round every time. So we're taking 107 and rounding it to 108. Take a look at the decimals. It'll tell you to round to 108. And we subtract the atomic number from that. So for silver, we are taking 108 minus 47, giving you 61 neutrons within silver. Now we're going to take a look at gold. So remember your letters in the center, AU, those stand for gold. We are going to figure out the number of protons, we're going to figure out electrons and your neutrons. Within your element at the very top, your atomic number, remember that tells you your number of protons and electrons. So for gold, your number of protons is 79 and your number of electrons is also 79. Trying to figure out your neutrons is a little different. So remember, you are rounding your atomic mass that you find at the bottom. So in this case, when we round for gold, your atomic mass is going to be 197. From there, we are going to subtract the atomic number. So 197 minus 79. That's how you figure out how many neutrons you have. So for gold, what you should have typed in is protons 79, electrons 79, neutrons. Make sure you show your work so you're able to look back at this and figure it out. But your total number of neutrons for gold is going to be 118. Let's see if you can try one on your own. So go ahead and pause the video, see if you can figure out protons, electrons, and neutrons just like we did for gold. This time you're doing it for iron. Specifically for iron, remember your letters in the center, Fe, that stands for iron. To figure out your protons and electrons, you guys are using your atomic number, which is found at the top. So in this case, for iron, the number is 26. So for iron, you will have 26 protons and 26 electrons. To figure out how many neutrons you have in iron, you're taking your atomic mass and rounding. So you should be rounding to 56, and you are subtracting your atomic number from that. So 56 minus 26 is going to give you 30. For iron, your protons and electrons are 26 and your neutrons are 30. Getting into a different aspect, so we're going to talk about physical and chemical changes. So for a physical change, these are usually about the physical states of the matter. So whether it's a liquid or a solid or a gas, that's what we're paying attention to. So a physical change is a change to matter in which no new matter is formed. So it's going to be the same item no matter if you freeze it, if it's a solid, liquid, gas, no matter what it is, it's still the same thing. So a great example of that is water. So in liquid form, you have your water, nice glass of water. You can freeze it, make it ice, and then also as you boil water and the steam comes up, you're also helping to evaporate it, and water is now a gas. So no matter which of those three states of matter water's in, it's still the same thing. So all you are doing is physically changing it. You're changing the look of it. When you're looking for physical changes, some things to pay attention to is maybe the change in color, the shape of it, the state of matter, just like we talked about with water, ice, and gas. Or you can even pay attention to the volume of a substance. So physical changes is you're just changing color, shape, state of matter, or volume. For a chemical change, this is when the particles in the matter change and new matter is formed. So a great example of this is if you guys ever cook pancakes or waffles, or maybe you're into baking cakes on the weekends. When you're cooking food, you are making an entirely new item. So you can mix flour, eggs, milk, and oil, mix them together. But once you bake that and maybe make pancakes or waffles or that cake you really wanted to bake, you can never get those items back out. So once you cook it, you cannot separate and get your egg back. You can't get your flour back, milk, oil, any of that. So that's how you know a chemical change has taken place. So when you cannot get those original items back, that's a telltale sign chemical change has taken place. A couple other examples are burning. So if you guys like to do bonfires in the summer, maybe you have a fireplace inside, or maybe on your patio there's a fire pit. Once you burn that wood and it's catching on fire and burning, you can never get that piece of wood back to how it originally was. It's gone. You can't get it back. That's a sign of a chemical change. There's specific things to look for when you're trying to figure out and distinguish, oh, did a physical change take place or chemical? So when you're looking at a physical change, you're looking at changes in the form of a substance. Remember, we talked about ice, water, gas. You're just changing the form it's in, not specifically what the item is. So some more examples are if you are drinking a can of pop, so maybe you're drinking some Coke. If you go to crush that can, you're not changing what it is. It's still a can. You're just changing the physical appearance of it. Same thing for glass. If you are walking around, maybe you accidentally drop a glass out of your hand and it shatters all over the ground. You're not changing what that glass was made of. You just changed the shape of it. So if you really wanted to, you could pick up all of those pieces off of the floor and glue them back together, and you would have your glass again. Okay, so you were just changing the shape of it. You weren't changing what it is. Another example is if you were to mix sand and water together. Yeah, when you stir it up, the water may get a little cloudy. You may not see your sand in a big pile. But if you let that water settle and maybe even evaporate out, you can definitely get your sand back exactly how it was. One more example is chopping wood. So if you have a dead tree that has fallen and you're chopping it up, all you're really doing is changing the shape of it. So just because you cut it up into a lot of pieces doesn't mean you're changing what the item is. You're just changing the shape of it. For a chemical change, there's different things you're looking for. So when chemical changes take place, you cannot get back your original substance. So you're looking for bubbles, you're looking for heat, you're looking for new substances being made. Another telltale sign is change in color. So if you've ever eaten an apple and you decide to put it down for a little bit and come back after a little while, you'll notice that apple has started to turn brown. So that's a sign of a chemical change. You're never ever going to get that original color of the apple back because chemical changes are taking place as you leave it sit out. The last thing you could look for is the change in odor. So these are all signs that a chemical change is taking place. When we talk about chemical potential energy, the definition states that chemical potential energy is the position and arrangements of the atoms within a substance. So when you rearrange those atoms into new positions and form new substances, remember forming new substances, chemical reactions, after you make those new substances, evidence that the energy has changed. That's what you get when you leave apples out. There's evidence that your energy has changed and your substance has changed. If you don't understand the differences between physical and chemical changes, there's 2 videos linked here for you. I would love you to watch at least one of them. Just because we can't really have class discussions or anything like this kind of just takes your knowledge and has it explained to you in another way, so maybe you'll understand it a little better. So before moving on in the video, at least watch one of the 2 videos. With your chemical reactions, this is when 2 substances mix together and the temperature changes. So when the temperature changes, that's a clue that a chemical reaction has occurred. So there's a couple examples that I think kind of relate to you guys for this. So if it's football season and it's really cold out, maybe a lot of you guys have hand warmers. So as soon as you start shaking those hand warmers to get them warm, you are releasing heat energy due to chemical reactions. So the items that are within your hand warmers, they're mixing together and creating that heat. Another example is glow sticks. So before cracking your glow sticks, there's no light, there's no nothing. And once you release those chemicals and you're helping them mix together, you are emitting light off. So that light energy is due to those chemical reactions. So when the temperature decreases during a chemical reaction, this is called an endothermic reaction. So when your temperature decreases, it's endothermic. When your temperature increases, that's called exothermic. So increases is exothermic. As we just said, exothermic, you're increasing, think of fire. Endothermic, you're making it colder, ice. With endothermic reactions, so a reaction that results in a decrease in temperature. I know this is repetitive, we're just trying to get it into your head for now. So endothermic is decrease. Exothermic is a reaction that results in an increase in temperature. So exothermic is an increase. Before moving on, what you need to do is watch this virtual lab. So this lab shows what happens when you mix baking soda and vinegar together. As you first start, you'll see different glasses, different colored water in there, and then they add water and baking soda together. Nothing happens even when they mix it up. And then after, they add different amounts of vinegar to each of the glasses, and you'll see what happens. So go ahead and watch your lab before moving on. So as you watch the lab, you're trying to think of the results. So what kind of reaction did you witness when the baking soda and vinegar were mixed together? So kind of go ahead and tell what kind of changes you saw. What kind of reaction did you see? So highlight your correct answer. So what kind of reaction is this? So this next part is a little more complicated for you to do because you weren't able to do it yourself. So when you were mixing baking soda and water together, baking soda and vinegar, I'm sorry. When you mix those 2 substances together, your reaction that happens, it ends up getting colder. So would that be an endothermic or an exothermic reaction? And then go ahead and answer the next two questions and pause your video. So pause your video as you answer your questions. Going back through your answers, so what kind of reactions did you witness? You should have seen bubbles in your video. Temperature changes also occurred, but you guys weren't able to see that firsthand, so go ahead and add that into your answer. And then the kind of reaction that this is a chemical reaction. Remember when we had a slide and it listed a whole bunch of things for you to look for? Bubbles was on the chemical reaction side, so that kind of helped to pick out that it was a chemical reaction. Since when you mix the baking soda and vinegar together, I told you the mixture got colder, you should have chose that it was an endothermic reaction because endothermic gives you a decrease in temperature. So how you know that is that the temperature decreased during the reaction and it gave off heat to the surroundings. Your last question asks, so was energy created or destroyed during this experiment? So energy is a lot like matter, so you cannot create or destroy it. So no, energy cannot be created or destroyed. And I hope this worked. If you guys have questions or you are very confused, either email Mr. Stratton or myself, and we will be happy to assist you in whatever way possible.